To get started, let's open up Visual Studio and once again create a new Visual C# WPF application. We'll call our new application Layout with Grids, click OK, and once again when Visual Studio settles down, we are in the grid in the window of main-window.xaml. Notice that the window has a height and a width, which will serve as a constraint on the grid. The grid can be smaller, and we can set a height and width explicitly for the grid, but it can't be larger than the window. Grids typically consist of rows and columns, and you create those by creating row definitions and column definitions. For example, we might type grid.rowDefinitions, and within the row definitions, we can create row definition objects. Each row definition can define the height of the row, and it can do so in a number of ways. One way that it can do so is proportional, or star sizing. The reason it's called star sizing is that you mark the height with a star or an asterisk, possibly with a number before it. The default, if you don't put anything, is height equal 1 star or height equals star. So if I were to create a second row definition and not put a height, that would be the same thing as having height equals star. You can create other rows where you set the height equal to, for example, 2 star. What this will do is it will look and say, well, I have 3 rows, 2 of them are star and 1 is 2 star. So I have 2 star plus 1 is 3 plus 1 is 4 star. I'm going to take the entire height of the grid, divide it by 4, give one of those 4 to the first row, one of those 4 to the second row, and 2 of those 4 to the last row. If I come along and add a couple more rows, I now have a total of 6 rows, but 8 stars. 1, 2, 4, 6, 7, 8. And so what it is going to do is divide the height into eighths and give 1/8 to each of the 1 star and 2/8 to each of the 2 stars. We can see that by creating rectangles in each of the rows. Here's a rectangle for the first row. Notice that it says grid row equals 0. We use a 0 offset, so the first row is at row 0. And in fact, row 0 is implied, so we don't even have to put in row 0. Although for all subsequent rows, we would have to put in the grid row. Let's add a second rectangle, and you can see that that is at offset 1, or the second row. Let's fill in all 8 rows. With all 8 rows filled in, we can run this application and see how they are distributed. Let's click Start, and you can see immediately that the 2 star rows are taking up twice the height of the 1 star rows. That's proportional sizing, and we'll be using that quite a bit with the grid. The other common ways of sizing are to give a specific size in device-independent pixels, which we'll call pixels from now on, or to mark the row height auto, which says size the row to the items that are in the row. We can create columns in much the way that we create rows by creating grid column definitions. And let's create 2 columns in the proportions 1 to 2. So we will say column definition, width equal star for the first one, and we will say column definition, width equal 2 star for the second. As you would expect, this means that the first column will take up 1/3 of the width of the entire grid, and the second column will take up 2/3. If you don't mark in your object which column you want to be in, then you will be in column 1. If you want to be in column 2, you need to set grid.column equals 1. Remember, 0 offset. I've rearranged our rectangles so that they take up just the first 4 rows, but both columns in those 4 rows. Let's run the application, and you can see the 1 to 2 width of the columns. Those that are in the right-hand column are in column grid.column1, and those on the left are in grid.column equals 0, which is the default. Let's add a label to the bottom of our grid to describe what we have. Our label's content is rectangle showing column width. We've set the font size to 24 to make it nice and readable, and we've put that in the 5th row, that is grid.row equal 4. When we run the application, unfortunately our label is cut off because it's in column 0, that is the first column, and it doesn't have enough room. We would like that to span the 2 columns. Also notice that the G is cut off, and that's because we're using proportional spacing, and what we'd like is for this row to be spaced to fit this rectangle. Let's make those 2 corrections. The first thing is we wanted it to span 2 columns, and we can do that by saying grid.columnSpan equal 2. There is, of course, also a row span. We could have this span 2 rows, but what we'll do instead is have row 4 size to auto. So here's row 0, 1, 2, 3, 4, and instead of using star sizing, we'll use auto, which says size yourself to fit your contents. To see the impact on the row below, let's add 2 more rectangles. So we've added a wheat rectangle in the left column of row equal 5, that is the 6th row, and a purple rectangle in the right-hand column. Notice that our label now has plenty of room. It's spanning 2 columns, and it's tall enough because it's been sized to auto, and the remaining row uses the remaining space. In fact, the way the space is computed for the star sizing is that the auto row is allocated, and then all of the remaining space is proportionally allocated, which is why the purple row is the same height as the green and orange.